Dear students, after studying this module, you shall be able to know about the importance of carbonyl compounds, design the synthesis of the carbonyl compounds from alkynes, understand the synthetic pathways of carbonyl compounds from organometallics, do the retrosynthetic and synthetic pathways of symmetrical and unsymmetrical ketones, know the synthetic pathways of ketones from nitriles and active methylene compounds. Carbonyl compounds in organic chemistry is a functional group consisting of carbon atom possessing a double bond to an oxygen atom. This is common to several classes of organic compounds. These compounds are useful in food, pharmaceutical and other materials. The carbonyl double bond in the carbonyl group is very susceptible to chemical reactions. Aldehydes, ketones, carboxylic acids and their derivatives including amides are the class of compounds possessing the carbonyl group. Carbonyl compounds from alkynes. The carbonyl compounds can be synthesized using various starting materials. Alkynes are an important starting material to synthesize carbonyl compounds. The terminal alkynes are very useful reagents for making carbon-carbon bond in organic synthesis. The alkyne anion acts as an acyl anion equivalent in the synthesis of ketones as shown here in the figure. As can be seen here in the figure, the cleavage of the carbon-carbon bond by the retrosynthetic approach gives the acyl anion from the alkyne end of the molecule. Synthesis of acetone. Acetone is a simplest ketone having the IUPAC name propane 2-one. The retrosynthetic pathways are shown here in the figure. The retrosynthetic analysis show the functional group interconversion tracing back the synthones to alkynes. The synthesis involves the acid catalyzed hydration of alkynes in the presence of HgSO4 results in the formation of enol which are tautomerized to form the carbonyl compounds. Here propyne reacts with water in the presence of HgSO4 and sulfuric acid to give the enol form which tautomerizes to acetone. It is the hydration as per the Markovnikov rule. Synthesis of butane 2-one. Butane 2-one or 2-butanone is a 4-carbon carbonyl compound. The retrosynthetic and the synthetic pathways are given. The retrosynthetic approach shows that the 2-butane 2-one can be synthesized from 1-butane. The functional group interconversion traces back the 1-butane as the synthon for the preparation of the desired product. The reaction of 1-butane with water in presence of HgSO4 and H2SO4 takes place as per the Markovnikov addition of water on the alkyne moiety, giving enol form which then tautomerizes to 2-butanone. The carbonyl compounds from organometallic compounds. These are the compounds having at least one carbon-metal bond. Metal being more electropositive than carbon acquires a positive charge while the carbon acquires a negative charge and thus is very electron rich. This is shown here in the given figure. The metal used could be magnesium halide, it could be lithium, copper or zinc. Thus organometallic compounds provide a nucleophilic carbon capable of donating an electron pair to an electrophile. Various substrates react with organometallic compounds to form the carbonyl compounds. Acyl chlorides form carbonyl compounds on reaction with organocadmium compounds, lithium dialkyl cuprates, etc. Organocadmium compounds represented as R2CD. Grignard reagents on reaction with cadmium chloride form organocadmium compounds R2CD as shown. The Grignard reagent as can be seen, forms dialkyl cadmium compound. Preparation of Gilman reagent, lithium dialkyl cuprate. Organolithium compounds on reaction with copper iodide forms Gilman reagent as shown, which is dialkyl cuprate compound. Synthesis of symmetrical ketones. Pentane 3-one is a symmetrical ketone. The disconnection approach and synthetic pathways of pent 3-one is given. Retrosynthetic analysis of pentane 2-one undergoes heterolytic cleavage between carbon-carbon bond, where one carbon is the carbonyl carbon, leading to the formation of a cation and anion. The cation portion can be obtained from acyl chloride and the carbanion from lithium dialkyl cuprate or organocadmium compounds, because we have seen that the reaction with the metal leads to the formation of a carbon with the negative charge, forming a carbanion. The synthetic approach involves the synthesis of pentane 2-one by two methods. Firstly, diethyl cadmium reacts with propenyl chloride compound A and form pent 3-one as shown. In the second method, lithium diethyl cuprate compound B reacts with propenyl chloride and forms pent 3-one as shown here in the figure. Synthesis of unsymmetrical ketones. Butanone is an unsymmetrical ketone. The disconnection approach and the synthetic pathways leading to the desired product are given here in the figure respectively. Retrosynthetic analysis of butanone undergoes heterolytic cleavage between carbon-carbon bond, where one carbon is the carbonyl carbon, leading to the formation of a carbocation and a carbanion. The cation portion can be obtained from the acyl chloride as shown in the reaction for the symmetrical ketones, and the carbanion obtained from the lithium dialkyl cuprate or organocadmium compounds as shown here in the figure. The synthesis of the same butanone can be achieved by two methods. Firstly, dimethyl cadmium reacts with propenyl chloride A and forms but 3-one as shown here in the figure. Second method involves lithium dimethyl cuprate compound B reacting with propenyl chloride and forms but 2-one as shown. Carbonyl compounds from nitriles. Nitriles react with Grignard reagents R MgX and form amines. Amines are further hydrolyzed under acidic conditions to form ketones as explained in the given sections. Looking into account the synthesis of acetophenone. Retrosynthetic analysis. Acetophenone or 1-phenylethane 1-one or methyl phenyl ketone undergoes a heterolytic cleavage between the carbon-carbon bond, where one carbon is the carbonyl carbon, leading to the formation of a carbocation and a carbanion. The cation portion can be traced back from nitrile and the carbanion from the Grignard reagent. Henceforth, we have two precursors, precursors A and B, which can be used in the synthetic route for the formation of the desired product. The synthesis of acetophenone can be achieved in three steps from phenyl magnesium bromide and acetonitrile. In the first step, phenyl bromide reacts with magnesium in the presence of dry ether and forms phenyl magnesium bromide. Phenyl magnesium bromide B reacts with acetonitrile and forms imine. Imine on further acidic hydrolysis can lead to the formation of the acetophenone. Carbonyl compounds from active methylene compounds. Active methylene compounds contain acidic hydrogens, Ethylacetoacetate EAA and diethyl malonate DEM come under the category of active methylene compounds. In both the compounds, the electron withdrawing groups present on both the sides of the methylene group, that is CH2 group, makes it highly acidic in nature. Abstraction of acidic proton from either EAA, ethylacetoacetate, or diethyl malonate generates an enolate anion which can be regioselectively alkylated as shown here. In the presence of a base, an anion is generated which can undergo resonance leading to the formation of an enolate anion, which in the presence of the alkyl halide leads to the substitution of the alkyl group at the active position. In the presence of the dilute base, hydrolysis takes place, forming the carboxylic acid, which then gets decarboxylated to form the alkyl group at that end of the molecule. Synthesis of ethyl acetoacetate. Retrosynthetic approach of the preparation of ethyl acetoacetate traces back the precursors as ethyl acetate for the preparation of the desired product. The synthesis can be carried out as the following steps. In the step 1, ethyl acetate on reaction with the base sodium ethoxide forms the corresponding anion 1, which is resonance stabilized. In the step 2, carbonyl 1 reacts with the another molecule of ethyl acetate and forms ethyl acetoacetate. This reaction is known as Claisen condensation. Synthesis of precursor of 2-acetyl 5-methyl hex 4 enoic ethyl ester. Can be seen that the synthesis can take place by the steps wherein the precursor through the retrosynthetic approach were considered as 1-bromo-2-methyl propene. Ethyl acetoacetate on reaction with the base forms a corresponding enolate anion which is resonance stabilized. In the presence of a base, the anion is generated which undergoes resonance to form the enolate anion which gets condensed with 1-bromo-2-methyl propene forming the desired product. To summarize, the carbonyl compounds in organic chemistry is a functional group consisting of carbon atom possessing a double bond to an oxygen atom. Alkynes are important starting materials to synthesize carbonyl compounds. Acid catalyzed hydration of alkynes in presence of mercury sulfate results in the formation of enol, which are tautomerized to form carbonyl compounds. The butane 2-one can be synthesized from 1-butene. Organometallic compounds are also being used to synthesize carbonyl compounds. The retrosynthetic and the synthetic pathways of symmetrical and unsymmetrical ketones have been explained.